Hello there, this is an Algebra 2 video. It is Chapter 10, Section 2, and today we're going to be talking about arithmetic sequences and series. So to begin, I want to remind you in Algebra 1, we saw this formula for the nth term of an arithmetic sequence. And in the previous section, we saw how arithmetic sequences can be linear, and you can find an equation that models an arithmetic sequence using a linear function, but today we're going to be using this formula. And I just want to tell you what all of the variables represent. So we have a sub n equals a sub 1 plus n minus 1 times d. A sub n represents the value of the nth term. So if you want to find the fifth term in a sequence, for example, let's say you had 2, 4, 6, 8, and this is your sequence, and you wanted the value of the nth term. So a sub n would be, if you wanted a sub 3, you're asking for the third term in the sequence, but you want the value of that third term, so you want 6. That would be the value of the nth term. A sub 1 is the value of the first term, which in this case is 2. And then d is the common difference, which we talked about in the previous section. And in this case, 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6, so the common difference would be 2. And then, of course, n is the term number. So this would be term 1, term 2, term 3, term 4, and so on. So I just want to make sure that you're aware of what all of those variables represent, and we're going to use them in our example. So example 1 says, find the 12th term of the arithmetic sequence 9, 16, 23, 30. So the 12th term would be n equal to 12. And they want us to find the value of that 12th term. So they're actually asking us to find a sub 12. So we're going to go ahead and just plug that right into our formula. But the first thing we have to do is a sub 1, which is 9, plus n minus 1, so remember n is 12, times the common difference. And we don't have the common difference yet, so we're going to come over here and we're going to do that. 16 minus 9, and then we're going to go 23 minus 16, and of course 30 minus 23, all of which give us 7. So our common difference is going to be 7. So we plug that into our formula, and then we just find the value. 9 plus 12 minus 1 is 11. 11 times 7 is 77. And 77 plus 9 is going to be 86. So it turns out the 12th term of this arithmetic sequence is 86. And that's how you do that. So now we're going to let you try these examples here and do it yourself, number 1. And then we're going to go to example dose. In example 2, it says, write an equation for the nth term of each arithmetic sequence, and we have 2 of them. And in the first one, we don't know what the value of the common difference is. It's not given to us. You can see in part B that they tell us that d equals 6. So we're going to go ahead and find the value of d first. So again, we're going to go negative 13 minus 5. Which is going to be negative 18, and then negative 31 minus negative 13, which is actually negative 31 plus 13, which is also going to be negative 18. So our value of d is now negative 18. So for our equation, we're going to say a sub n is equal to the value of the first term, which in this case is 5, plus n minus 1 times negative 18. And of course we can simplify that, so we can say negative 18 times n is negative 18n, and negative 18 times negative 1 is positive 18. And then lastly, we want to combine our like terms. So we have negative 18n, and then 5 and 18 would give us 23. And so we get a sub n equals negative 18n plus 23 for our equation for our first example in part A. So now in part B, it's a little different. because we are given a sub 5. We're given the fifth term in the sequence, and we're given the common difference, but we don't know what the first term is. So we need to figure out what the first term is before we can go any further. So to figure out the first term, we're going to work with our formula a little bit backwards. So we're going to say a sub 5 is equal to a sub 1 plus n minus 1 times d is our formula. So we're going to go ahead and plug in everything that we know. We know that a sub 5 is 19. We don't know what a sub 1 is, but we know that n is 5 because we're trying to find, because we're using that a sub 5 is 19. So we're going to put a 5 in for the n, and then the common difference we know is 6. So 5 minus 1 is going to be 4. So we have a sub 1 plus 4 times 6, and of course 4 times 6 is going to be 24. So we're going to subtract 24 from both sides, and then 19 minus 24 is going to give you negative 5. So it turns out that a sub 1 equals negative 5. So now that we have the first term, we can go back and plug it into our formula. So we're going to get a sub n is equal to the value of the first term plus n minus 1 times our common difference of 6. And now we want to simplify just like we did in the previous example. So we're going to say negative 5, 6 times n is plus 6n. 6 times negative 1 is minus 6. And then we want to combine our like terms. We have our 6n, and negative 5 and negative 6 is going to be negative 11. So our formula will be, or our equation will be a sub n equals 6n minus 11 for part B. So now we'll have you try this, these two examples here and do it yourself, number 2. And then we're going to go to example 3. In example 3, we have something a little different, and it's what we call an arithmetic mean. Sometimes you have a sequence that's given, and you don't know what the values in between these little guys are. And so the terms between any two non-consecutive terms of an arithmetic sequence is called the arithmetic mean. So sometimes you can have 4 in between, 5, 2, but anytime you have terms that are in between non-consecutive, consecutive means one after the other. So clearly these are not one after the other, there's 4 in between. So these guys in here are what we refer to as arithmetic means. So we can actually use the arithmetic means, and we're going to try to find them here in example 3. Sorry, my throat is giving me a little bit of an issue. Find the arithmetic means in the sequence. So how do we do that? Well, first, we have to recognize that there are 4 terms between the first and last terms that were given. So how many terms total are there? We know that n equals 6. Because we have 1, 2, 3, 4, 5, 6. So we know that n equals 6. And we don't know what the common difference is. And we don't know so we don't know the common difference, and we need to find that. So what we're going to do is we're going to use our formula to help us find the value of d. We're going to go ahead and use one of the terms that we already have, like for example 22, and we're going to find our d value. So we're going to say 22 is going to be the 6th term because n is 6, so we're going to go a sub 6 is equal to a sub 1, which we know is negative 8, plus n minus 1, so n is 6, remember, times d, we don't know what d is, and then a sub 6 we know is 22 because the value of the 6th term is 22, so we're going to go ahead and replace that with 22, and then we're going to solve for d. So we're going to go ahead and add this 8 over here, and you're going to get 30 equals 6 minus 1 is 5, so you're going to get 5d. So we divide by 5, and it turns out that d equals 6. So now that we know that d equals 6, we can go ahead and find the other values because Well, all we have to do is add the common difference to each term. So negative 8 plus 6, negative 8 más 6, is going to give you negative 2. So let's come over here, and we're going to fill in these question marks with negative 2, and then we're going to add 6 to that, and we're going to get positive 4, add 6 to that, we're going to get 10, add 6 to that, we're going to get 16, and then you're back to 22. So we can use the formula for an arithmetic sequence to find the arithmetic means when we don't have the ones that are in between, just like so. So we're going to now let you try this example. And then we're going to go to an arithmetic series. An arithmetic series is the sum of the terms of an arithmetic sequence. So basically, if you had an arithmetic sequence and you wanted to add up all the terms, whatever that sum would be, that's what the arithmetic series is. And so, because an arithmetic sequence goes on forever in most cases, we have what we call a partial sum. We want to find the sum of a certain amount of terms. So S sub n is the symbol that we use for a partial sum, and it basically means the sum of the first n terms. So if I have S sub 5, it means that I want the sum of the first 5 terms. If it's S sub 20, it means that I want the sum of the first 20 terms, and so on. We have two versions of the formula here. I actually prefer the first one. S sub n equals n, we know that's the term number. A sub 1 is the value of the first term. A sub n is the value of the last term, and then divided by 2. Or we have this formula, and you can kind of see the formula for the arithmetic sequence here, you know, the A sub 1 plus n minus 1 times d, but you have 2 times that, and it's times this. But this just is a lot longer, and I just prefer the first one. But you can actually use whichever formula you think is easier for you. So here we go in example 4. It says, find the sum of 12 plus 19, 26 plus, and you see the dot, dot, dot here. So we know the first term, we know the last term, but we don't know all the terms in between. And we don't need to know them in order for us to get this little guy. So we're going to get that we need to find n because we don't have n yet. So if we don't know what n is, we can't plug it into the formula. So let's go ahead and find n. And we can find n by using our formula for an arithmetic sequence. So we're going to go 180 equals a sub 1 is 12 plus, we don't know what n is, so n minus 1. But the common difference we can get very easily because you can see here that each one is increased by 7. Or you can just do your thing here. 19 minus 12 is going to be 7. And then 26 minus 19 is also 7. So we know that our common difference here is going to be 7. So, just checking my work here. Make sure I have everything right. Don't want to go back and have to do it again. So there we go. So now we're going to solve for n. We're going to move this 12 to the other side. 180 minus 12 is going to give us 168. And then we're going to have 7n minus 7. If we distribute the 7 here, we're going to add that 7 to the other side. So 168 plus 7 is going to give us 175. And then we divide by 7. And the value of n is 175 divided by 7, which is 25. So the 180 here is the 25th term. And so to find the sum of it, all we have to do now is plug it into the formula here. So we're going to say S sub 25 is equal to n times the value of the first term, which is 12, plus the value of the last term, the 25th term, 180, divided by 2. So 180 plus 12 is going to give us 192. 192 divided by 2 is going to give us 96. And we multiply that by 25. So 96 times 25 is going to give us 2,400. So S sub 25 equals 2,400. Now another way of doing this will obviously be to recognize the common difference and then add 7 until you got to 180 and then count how many terms you had. But that would just be ridiculous. And then you have to add them all up, so it would just take a lot longer. It's a lot easier if you use the formula. So that's how you use the formula to find the sum, the partial sum. And so now we're going to let you try that for do-it-yourself numero cuatro. There we go. And then we're going to go to example 5. Awesome. Example 5 says, find the first 3 terms of the arithmetic series in which a sub 1 equals 7, a sub n equals 79, and s sub n equals 430. So, clearly we don't have all the information that we need to have. One of the things that we need here is to figure out what n is, because if we don't know what n is, then we're kind of doomed. So we're going to use our series formula this time to actually solve for n. So we know that s sub n equals 430, so we're going to go ahead and plug that in. So we'll get 430 is s sub n, our partial sum, and the formula says that you take n, which again we don't know what it is yet, times a sub 1, which we do know is 7, plus a sub n, which we know is 79, divided by 2, and we're going to find n. So 7 plus 79 is going to give you 86, and 86 divided by 2 is going to give us 43, so we're going to get 43n equals 430, and of course we divide by 43, and we're going to get that n equals 10. Once we know that n equals 10, we need to find the value of d, because you want to find the first 3 terms. So we need to know what d is. So now to find the value of d, we're going to go back to the arithmetic sequence formula, which was a sub n equals a sub 1 plus n minus 1 times d, this formula. So remember, don't get them confused. We have an arithmetic series formula and an arithmetic sequence formula. So the series formula was the n times a sub 1 plus a sub n divided by 2 formula, and this is the sequence formula. So now we've already used the series formula to get us the n value. Now we need to use the sequence formula to get us the d value. We didn't use that one to find the n value because we have too many variables. We didn't know n and we didn't know d. So we have to use this one first to find n, and now we can use this one to find d. So we're going to go ahead and come over here, and we know that n is 10, so now we can say that the value of the nth term is 79. We already knew that from previously. The value of the first term is 7. And now we know that the n value is 10. So 10 minus 1 times d. So we're going to move this 7 to the other side. That's going to give us 72. And then 10 minus 1 is actually 9, so we get 9d. Divide by 9. And 72 divided by 9 is 8. So our d value is now 8. And now that you know what the d value is, now we can find the first 3 terms. So the first term is obviously 7. And then we can add 8 to that. And that's going to give us 15. And then we add 8 to that. And that'll give us 23. So the value of the first 3 terms is are 7, 15, and 23. So that is how we use the formula for an arithmetic series to find the first terms of an arithmetic series. And now you can try that with this example. And then we're going to go to our last concept for today, which is actually sigma notation. And it looks kind of scary, but I'm hoping that we can understand it together. Here we go, sigma notation. So sigma is this little guy right here, and I know it looks like an E, and I'm not a linguist, but this symbol I believe is supposed to be an S, like a Greek S, and I know it looks like an E, but it's not, and so basically it represents sum. I think it's supposed to be an S for sum. So it doesn't really matter where the symbol came from, But when you see this symbol, it's a funky looking E. If you want to know how to make it, you can kind of watch what I'm doing here. You kind of just do this little guy. All right, it's just a funky looking E. But it represents sum, okay? So what it's telling you is that you want to add all of the values, okay? So this little number down here, you'll always see the symbol with the number down here. It'll have a variable. It doesn't have to be k all the time, but it'll say k equals something, and then it'll say the n on top. What this number tells you is where to start, and this number tells you where to stop. And that's going to make more sense if you're confused right now when we get to the example, but I just want to show you what the terminology of this symbol means. So the first value of k, you start here, last value of k, you end here, and this is actually the formula for the terms of the series. All right, those are all the parts. So we're going to use that in this example here. You can see it again. You'll see what I mean. It says find the sum starting from the 4th term, ending at the 18th term of 6k minus 1. This is your formula. So what this means is, and before we get going, I'm just going to show you kind of what it means. We're not going to do them all because there would be too many of them. But what it means is you would start here. So you would plug 4 into this formula. So you're going to go 6 times 4 minus 1, and you're going to get a value. 6 times 4 is 24, and 24 minus 1 is 23. Then you're going to plug in the next consecutive number, which is 5. 6 times 5 is 30. 30 minus 1 is going to be 29. Then you're going to go 6 times 6. 6 times 6 is 36. 36 minus 1 is 35. And you're going to keep doing this dot, dot, dot until you get all the way to 6 times 18, because you start at the 4th term and you go all the way to the 18th term. So 6 times 18 is 108. Subtract 1, you get 107. Okay? So that's the first thing you're doing. That's not even the whole thing, because remember, this symbol means sum. So right now all we've done is we've plugged the number into the formula. And you have to do it all of these times. Okay? But what it actually means with this letter, with this symbol here, is that you actually then want to go and add all these together. What is 23 plus 29 plus 35 plus on and on and on until you get to 107? You want to add up all those terms. And you can tell that what's happening here is you're not starting with the 1st term. You're starting with the 4th term. So there's already 3 terms missing. So you're not doing this 18 times. You're doing it 15 times. Because you're not counting the 1st term, the 2nd term, or the 3rd term. So 18 minus 3 is going to give you 15. You're going to have 15 of these values, and then you're going to add them all up, and you're going to decide whether it's A, B, C, or D. Now this is a very complicated way of doing, you don't want to add up all of those terms, you don't want to evaluate all those terms, it's take forever. That's not what I'm suggesting you do. We're going to use a shorthand way of doing it, but I just want to tell you what it's actually representing. Okay, you're plugging in each thing into the sequence or into the formula, and then whatever value you get, you're adding them all up. So this single notation is just shorthand for what we already were doing earlier. So what we want to do is I'm going to go ahead and erase this now, and we're actually going to figure this out by using our formulas. The first thing I need to figure out is what a sub 1, a sub n, and n are. All right, so we already said earlier that n is 15 because 18 minus 3. So basically you always want to subtract 1 less than this. So I'm not going to go 18 minus 4. I'm going to go 18 minus 3 because it's 1 less than 4. If this was a 5, I'd subtract 4. I hope that makes sense. Okay, so n equals 15. And so now I need to figure out what a sub 1 is, but that's not hard to do because I have a formula. So a sub 1 is going to equal 6 times 1 minus 1, which is 6 minus 1, which is 5. So a sub 1 equals 5. I'm sorry, I don't know why I just did that. Erase that. Aha. A sub 1 in this case, because I'm not starting with the 1st term, remember? My 1st term in this case is actually going to be the 4 in there. So a sub 1, my 1st term is actually going to be 6 times 4 minus 1, which I already calculated earlier and I erased it, but it's 23. And then I want my last term. Remember, because to put in the formula, you need the first term and the last term. My last term, I already can figure out by plugging in a sub n is going to be the 15th term, right? So it's going to be 6 times 18. That's my last term. So I figured that one out earlier too and erased it. My bad. But I do believe it was 107. 6 times 18 minus 1, yes, 107. So there's my first term and my last term. And then all I have to do is plug it into the formula. And the formula says to go partial sum. We know that n is 15. So we're going to go, s of 15 is going to equal n times a sub 1, which was 23, plus 107 divided by 2. So 23 plus 107 is going to give us 130. 130 divided by 2 is going to give us 65. And 65 times 15 is going to give us 975. So now we know that the answer is C. All right? So first thing we did is identify n. All right? By subtracting 18 minus 3 was 15. All right? We want to find the value of the first term, which is going to start here with the bottom number. You want to find the last term, which is the top number. So plug those two numbers into your formula. And then you want to plug them into the series formula and get your value and determine which one of the choices is correct. So now you're going to have one that's similar. And so once you have completed this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class. And thanks for watching.